Okay. Hope everyone can see my screen. Fine. So today we'll be learning Git. Okay. So just a quick recap what we have covered till now. So last classes we have covered Hadoop with some basic examples or code snippets over there, how to work on top of RDD and data frame. So Hadoop on top of data engineering, we basically use these two data frames or these two data structures rather we can say. And on top of that, how we can code it by Python or maybe Scala scripting and how to load the data or how to work this thing as a ETL tool. Just like the data analysis or data manipulation on top of pandas, it's same kind of stuffs over here, but that should be distributed in nature. So that thing we have covered in last session. Hopefully you have some idea on top of that. If you have any doubt or anything, you can ask me. Okay, now or after the end of this today's session. Okay, fine. So today we'll be learning Git. Git is for storage purpose. Whatever code we are building for our. Suppose we are in a business. Just give me 1 second, please. Just have a call to take. Sorry for that. So suppose we are working in our business or in with our client. Okay. So whatever code we are developing over there, that code needs to be stored in some repository. Okay. So that particular repository is maintained by Git. It can be Git, it cannot be Git, but Git is the most popular one, and it's basically used for version control system. Why version control system? Because we are developing the code. Suppose we are the developer. So at the initial version, it should be very basic, and after that, each of the enhancement are getting added to that particular code versions. Suppose we are working in a data engineering, and in the data engineering, both of Python and SQL will be required. Okay, so each day we are typing some codes in SQL as well as in Python side. Maybe there are two repository. One is storing Python codes and another one is storing SQL codes. Okay, but those two repository can be controlled by version because maybe suppose in each Friday we need to commit our changes. Whatever changes we have built for a particular sprint, we need to review it by some other person. So our repository should be up to dated so that our team lead or architecture or product owner can check it. So for each Friday, we need to check this thing whether the version has been properly committed. Suppose we have initial version, then against next Friday, some enhancement can be added into the SQL. So we can have some more queries over there. We can have some more codes in Python side as well. So the two repository can be version control. So version 1, version 2, version 3, just like this. And why it's version control? Because suppose I'm currently working in version 4, okay, but I have the access what thing has been done at the version 1, 1.0. So I can check the history, which version, whatever thing I have committed or whatever thing I have done, that can be checked. Okay. And Git is free and open source, of course, and Git is distributed in nature because for a particular repository that can be accessible by multiple people nowadays. For a big company or for a big project, lots of people or lots of resources are working on a single repository. Okay, and they are committing by their own whatever changes they require. They are individually committing that thing. What is commit and all, I'll be coming quickly. It's just like the same. I think you already gone through that SQL transaction control language, TCL. So if we are making any changes at the DML side, we have to commit it. Commit means just saving it. Okay. Not exactly saving. Commit. The transaction can be committed into database so that any other who can joins the company or who can check the database after the commit, then that thing should be reflected to everyone in the same database. So the same kind of stuffs is there in Git. Whatever we will be committing, the changes should be pushed or changes should be present in the branches. I'll be coming in details. So I'm just trying to emphasize distribute means the thing is distributed, Git is distributed in nature so that everyone can access it. Okay, that's why it's called distributed. So what are the next topic today? We'll be discussing on top of Git. Git is required for all the project purpose, maybe Git or maybe any other version control system. But Git is the basic one. Specifically, most of the people, most of the projects use Git. Rather, Git is a software and GitHub is a service on top of that software. GitHub, GitLab. So mainly our company or every company use that particular services. Maybe GitHub, maybe GitLab, maybe any other one. Okay. So Git is the basic thing. I'll be coming what is Git and all. So today's topic was should be on top of Git. So just have a basic idea if we are just onboarding or onboarded in a particular project, so that we can. What are the changes? What are the terminologies on different Git action items and all? Just to have a quick idea on top of that. Okay, moving to the next slide. If there is any doubt or anything, any more thing you want to, learn or anything, please let me know so that we can cover up this thing or cover up this thing by today, or maybe I'll be just gathering some more information for the next day so that I can discuss the same with you. Okay. So what are the different features of Git? It can track changes across multiple files. So I told you we have the repository to store the files for Git, and it can track the changes. In the particular repository, there can be multiple files. There may be DDL files, there may be DML files. For Python, there should be various codes. So it can track changes for multiple files. Each of the changes, a single changes of the file itself can can be tracked by Git. And we have the capability of time travel into old version. That thing I just told you. Suppose I'm version 4, I can time travel to version 1. Whatever changes I have required, maybe we have done some wrong way for version 2, 3, 4. I have to work again from version 1. The new changes should be discarded because that is no longer used for a particular business requirement. If this is the scenario, we can time travel to the old version and we can start with the same from that particular version. Okay. So we can roll back this thing. Yeah, rollback is the same stuffs. The same kind of stuffs we have already learned in the TCL, just like save point and commit. Save point, rollback, commit. The same kind of stuffs we can do over here. Collaborate and share changes. The developers can share the changes amongst them. So for a particular file, a particular developer is working, then another particular file, another developer is working. But each of the files can be dependent of another one. Suppose I'm working as a Python developer. I created a particular classes. Okay. I import the package. The same package can be used by another one, another developer. So that's why whatever, we have a dependency from the previous developer to create the package and all. So as soon as he commit for the package file, that means that py file which is containing that package, another one should be using the same thing. Okay. So we have work, that collaborate and share changes are this kind of stuffs. Combine changes. Okay, we can combine the changes, compare version of a particular project. We can compare different versions of a project. So those are the features. That's why, Git or any other version control of systems is, those are very much useful in a, live project or just like this. Or suppose your code has been broken. Okay. So your database is down. No way to check the DDLs or DMLs anyway. If your database software is open or everything is fine, then you can export the DDL from the metadata of that particular database. That is fine. So someday it has been crashed out or something would have happened. you do not have any code bases there. So that is another main reason we can track the backup of the thing. Okay, so that it at any point of time we can deploy the same code again and get back our code. Maybe we do not have the data. Suppose in our table, we can store only the tables DDL or DML, but entire data set, whatever data we are getting, entry to this particular table, that cannot be with us in stored version of Git, because data cannot be stored in Git. It may be in another archival. We can store the archival thing in S3 bucket or Glacier, just like I told you earlier. But Git should only store the code versions. Okay. You have to deploy the DDL again. So when table is ready, then you have to check for your archival data and you can push the same into the table to bring back to the old version or old system again. Okay, fine. So moving on to the next topic. Okay, what is Git and what is GitHub? So it's not exactly the same. Git is a tool, or rather, you can say it's a software, and GitHub is a service which would be working on top of this software. Okay, there are various differences over here. Actually, when we are live with a project or it's a big project, we have to use a particular service, not only Git. Git can be used for our local purpose. Suppose I'm a developer, I am trying over there in my local system, I can install Git to my local system, I can create the repository and all. For GitHub, the backend thing is Git, obviously, but as we are using the services, it's a bit advanced over there. We are using or we are saving the thing in a portal. Okay, suppose github.com for that particular company domain as well. I'm working for XYZ company, so suppose the portal should be created such a way, github underscore xyz.com. Okay, in that particular portal, we are using this thing as the repository purpose, a remote repository where we can store all the code versions over there and we can save it over there. Everyone can check the thing, whatever the recent code is there from the portal itself. But Git is not the same scenario. We can install the software in our local and we can commit the change if any pull is required, any push is required into the particular file or anything. We can control everything by the software itself. No need of internet for that thing. Okay, it's just like locally in our system. The third point, and GitHub is hosted on the web. This is one of the main difference. Okay, I put lots of difference for just for your knowledge. You can check it. Uh, but the basic thing is this. Okay. The competitor of GitHub, there are, just I told GitLab, Gitbucket, AWS Code Commit. It's a AWS component as well. In the left hand side, Git is having those competitors. CVS, Azure DevOps Server. Although, I haven't used this kind of stuff. So I only used Git in my practical experience and all. So just to mention, all the competitors are there as well. But Git is the most popular one. Okay. Okay. Now, if you want to install Git at your local system, so this is the portal you can just quickly go through gitscm.com. Over there, you can install or you can download. Yeah, this is the portal and the latest version you can download. Whatever OS you are having, just download and install it. Then Git is present at your own machine and it should be look like in this. The software should be git bash. The particular icon should be created at git bash. Okay, so it's a command line tool. If you just double click on that one, it should work as a command line, just like the Linux interface. And if you're working at the putty side, it should be the same one. So how we can work at the local system? Just a quick reference. Although will be not be using when we'll be working as a team member of a particular live project. Actually, Git should not be used there. We just have to habituate it what is GitHub and all, because there it should be web based, as lots of developer would be working. But just a quick thing, what is Git? I mean, as the Git is there in our local, so how it should be working? Just a quick concept on top of that thing, I'll be just going to provide now. Okay, so suppose we have installed Git, and I can check that icon is present at a Windows Git bash. Okay, now how to approach with this thing? How I can manage everything at my local system? Okay, first of all, that slide I just put it over here. That should not be over here. So to control Git, I mean, if we just want to get rid of this, I mean, command line versions and all, I mean, command line tool, just like Git bashes and all, if we are not habituated with the command line, we can use lots of graphical user interface, which will be working on top of Git. That is called GitHub Desktop, Source Tree, Tortoise, Tower. Okay, so this kind of GUI is also present. Some of the company, they also use particular Git GUI. Not all the things are compliance to their company's policy. So you can check any one of them to be used for your company purpose as well, or project purpose. This thing should be working as your locally, and as well as that thing should be also using to push any changes into GitHub repository at website too. Okay, so those things can be working as an interface between your local system, local repository system, as well as your remote repository system. Remote means that is being hosted at your website. Okay, so now going back to our local repository, I'll be just focusing only Git now, not GitHub. So Git in my local, suppose I have a particular drive called a new folder, okay, under C drive. So I want to make this particular folder to be working as a Git repository. So whatever changes I can make on that particular folders, in that particular folders, particular files and other components, that can be managed or tracked by Git. If we declare that particular folder as a Git repository, then only that can be done. Okay, so Git repository, why it needs to be created? I mean, the same thing. The first slide we just I mean check that for the version control system, whatever changes we are making at our file system, that can be tracked over there. And repository needs to be created based on particular subject area. For a particular new project, we can create the repository. Now, how to create the repository for a particular, I mean, to be declared for a particular folder? This is the option. So suppose the folder is not, I mean, folder is there. So we can just have to go to this folder. On top of this folder, we have to open the Git bash. So that, I mean, we can also, I mean, go to Git bash. We can open the Git bash. We can put CD command to this, to go to this particular drive or directory. Then we just have to type git init. It should be initializing a Git repository to that particular folder. So underneath that folder, whatever structure should be there, any other folder structure, any other file, that should be controlled, or I mean the version will be controlled by Git. Okay. So that particular folder is should be a particular Git repository. At any particular over there, if I just open Git bash again, and if we just type git status, I can check if there is any uncommitted file. I have changed something. I have I mean something is needs to be committed, or any other thing, any other any particular status I want to get by having this command git status. I just put few commands which are very much important and which can be triggered to git bash only. The same kind of stuffs you can also find in particular GUI, but it's having all the keyword there, and those keyword is very much helpful. You just have to click on particular button and the particular repository will be created over there. If we just want to create some branch, it should be created over there. If we just want to commit, that is possible over there. But I just emphasize on some of the uh, command over there, which should be triggered through git bash. Okay. Later, I have some quick interfaces, graphical interfaces, screenshot or snippets over there. So you can also check it, how it should be working. Maybe I think you have already worked in other companies as well. You also know what is Git and how to control with the code versions and all from your project. But you can also just brush up your knowledge over here. Or, I mean, whoever totally new to join a company, you can have the idea how Git is working. Okay, because over there you have to work with several terminologies on top of Git. If there is any stuck point or any doubt till now, you can ask me over here. Okay, no doubt. So, in our local system, we are successfully able to create a new repository. Okay, and we can check anytime what is the present status or current status of the repository by Git status. Okay, yeah. So this is a graphical interface tool, GUI. So it's source tree. Whatever I'm thinking, maybe it's a source tree snippet. Source tree is a software. So this kind of code snippets, whatever I'm changing for a particular repository, so that thing can be shown over here. Over there, I can see those are called branches. What is branches? I'll be quickly coming into the latter chapters. Why branches is required? But in a particular branches, we can see the particular circular symbol over there is a commit because I'm saving something for that particular repository. And what kind of save I'm doing, what kind of commit I'm doing, it's called commit. Those are called commit points. Okay. And this is the entire version. I mean, version is being changed over here. I mean, a new version has been generated for the changes at for that particular commit. Again, there is some changes over there for that particular commit. And what are the particular changes we are doing? It's present in the description. Okay. So this way we can track it. Suppose I'm currently in this version. Okay. My code is this in this version. So I want to check what is there in our previous commits by checking or by hovering the mouse over here. I can also rebase whatever the change. I want a time travel and I want, suppose I have worked, this is the main developer or main branch, the green one. I started working whatever changes has been done till here, this commit portion. So I changes these two commits. Later I checked some issue is there with my changes or with my developed codes. So my lead told me don't go further, just take it from here again and start work. So I can discard those changes, just I can go to over here again. I can push the codes and I can change the thing and go ahead with committing part again. So I can have a time travel to the old history version and start work again. So this is the important feature of Git. Okay, and everything can be tracked over there by this kind of GUI as well. Whatever is suitable for you, or maybe as per your company policy, you have to work. But I have seen all of them should be using some of the GUI for your sake or for your, I mean, good to check what is the changes and everyone can quickly check it from here. Okay. Now, what is commit? Just whatever changes you are doing. So it's just creating a checkpoint. Okay. So suppose you are working for particular stuffs over here, you can make new files inside the repository, or you can edit some existing file, you can delete something. So first of all, you have to add the changes in some staging area, a stage area. Okay. Commit cannot be a single way. I'll be just going to this thing in the next slide. So we need to track all the changes first. I mean, to particular stage area. Suppose in a particular single day, I have to work lots of changes. Okay. So I can change all the thing. But at the end of the day, I can commit the thing. Okay. Because each line of code I'm changing, I'm quickly committing it. That is not a good practice or just like this. Because maybe lots of files I have to work. Okay, but you can also commit. There'll be no use. I mean, no use of that particular stuff. So you can all. I mean, commit all time. Just like any changes, you can commit it. But specifically, what we should do, just like working directory, by putting this command git add on git bash, we can add this thing in stage area. After that, we can execute git commit, which should store the changes at staging area to the repository. Okay, and a particular checkpoint should be there. Okay, give me 1 second, please. Okay, so till now, any doubt how to commit any changes? So whatever changes or enhancement we required, we can add the thing first in stage area by git add command. It should be in stage area. Lots of things should be present in stage area. Now I want to push all the stage area to my main code repository. Then we just have to, I mean, put the command git commit. Then all the code base changes should be present into the repository. Moving to the next slide. Yeah, creation of branches. So here is the concept of coming the branches because we have suppose 30 developers in our project. Okay. So each of the developer is working for a particular file inside a particular repository. Or maybe a single file can be used for a particular single file is having code based repository for particular sets of tables or data mart creation of particular uh, project. Okay, data mart creation means data mart, how the data mart population logic, there should be some DML script as well as some DDL script should be present as well. So someone is working DDL, someone is working DML. So this kind of stuff, lots of people or lots of developers should be working over there. So we have to create the branches, or the developer should have to create the branches. So each of the branch will track each of the developers work. Okay, so and there should be a master branch, the main branch. Master branch is the called main branch. What should be pushed to, or what should be deployed finally in the, I mean, dev environment or the latter environment, QA production. In our project work, there should be not only a development work environment. Development team can just work at the lower environment just to test everything. So when not only testing, sorry, developing the thing and for unit testing. So when everything is fine for the developer environment, then they will be deploy the change. Which change? Not their branches change, rather when their branches are is ready to commit, then they can commit the changes to the main branch, or they can merge their changes to the main branch, and the main branch can be deployed to the development environment as well as the upper environment. So the mini branches which a particular developer has worked for their testing purpose or any other purpose, or many for some POC purpose, so that will not be pushed to the main branches. Okay, so whatever is the finalized one. So I have tried everything for today, but I just want to make a particular changes to be commit to the main branch. Then I just have to merge the particular feature to the main branch which is required for the future usage, and the same master branch should be, the code of the master branch should be pushed into other environment, that means development, QA, then UAT. QA means quality. The QA team, the testing team will test it. Then that when the test will pass, then it should be migrated to UAT. So everything should be master branches, and the work whatever we can do for our trial purpose, that cannot be pushed or merged. I mean, all the thing cannot be pushed. Whatever is the required one, that can be pushed. So let me have some, yeah, I mean, quick diagram over there. Yeah, just like this. So this is the master branch, means this is the main branch. What should be pushed in our higher version till production. Production should be working with this code base. So I'm a new developer. I'm working. I just took, from this commit portion, I just took something, the particular code versions over here, and I started changes over here. So when my change is finalized, I can push or merge. That is called merge. I can merge my change to the master branch again, so that my changes, whatever I have developed, that should be pushed to the master branch, so that that can be deployed in the environment. Okay, so how to do that? By git bash. So while switching the branch, I just have to git switch master. So this is the command for git bash. So one new branch should be created over here. It is called feature branch as well. Okay, so when our feature branch change is ready, I can merge it back to the master branch. Okay, it's git merge feature branch. So automatically it should be pushed. The changes should be pushed to the master branch. Okay, this is the concept of branching and merging of the same into master branch. Okay, now a quick thing. What is merging conflicts? Suppose a particular developer uh, or something has been happened over here. When I was developing the code for a particular single file, the same kind of file again been handled by another developer, maybe another feature branch. They have pushed the changes over here. Maybe someone directly worked at the master branch itself and changes something for the same file, whatever I have worked over here, and the same file has been worked over here as well. So when I'm trying to push my changes from here to here, or I can merge the change from here to here, if whatever I'm just pushing, if the same file has been updated by someone else, then I can receive this kind of merge conflicts. Okay, so then we need to check, or we need to remove that conflicts. Manually we can do that. So whatever changes is required, maybe two different changes is there. So which changes should be there, or what should be the final change, or whether both changes should be kept it over there, we need to discuss between team members, and we need to manually remove that conflict and push it again over there. This is one part. Or better, the better thing should be there. There should be meeting for your daily basis, what particular changes has been done by which developer. So from this meeting, when you are just aware that someone has already made a change over there, so try to update this change, or try to pull that particular change before pushing your change. So whenever you will be pushing or merging your branch, just check it if there is any changes of the same code base. So just try to collect the latest version, then change it over there. Then no kind of merge conflict should be there, and that should be the good practice. Okay, so there are two kinds of way to remove that thing. Either you can edit this thing manually and push the change again over there, or just, not to occur this kind of stuffs, you can pull the latest master branches coded, and after changing the thing, after when no one will be going to change anything, then just finalize your code and push the same thing over there in the new code bases, and push it back to the main master branch. Okay, then no kind of margin conflict should be there. Till now, any doubt from anyone? uh, if there is any, please tell me. Okay, fine. Hopefully there is no doubt. So git stashing, this is another concept of git stashing. What is git stash? Okay, so suppose I'm a developer, so I'm working on a particular topic. Okay, there is a particular save point that is been finalized by the company. So till whatever I have developed till last 2 weeks, before 1 week ago, that is been finalized, so it is fine. So after this 1 week, I have modified some particular thing, but suddenly my team member or some team lead told me that nowadays the latest week, whatever I have modified, that changes is not required as of now. So that project has been postponed. Maybe that particular thing can come later. Maybe after 1 or 2 years, it can become again, uh, or it cannot. So as of now, it's not required. That particular thing or that particular code based changes is not required. So what we should do? That time Git stash will help me. So after the last save changes, whatever I have modified, so that thing I can stash it. Stash means it can be stored into some temporary location. And if I just run this command git stash, then whatever new changes I have done after the last commit to the master branch, all the changes, what I'm yet to be commit, it's not committed, it's not been saved. That particular changes should be inside the stash, a temporary folder. And that thing also be tracked in somewhere in stash part. So I can pop it whenever that particular thing I have stashed it, I can pop it again to work on top of that. So that is the command git stash pop. It should be popping this thing out again to my feature branch and I can work it later as well. So as of now, if the changes or whatever changes I have done, it's not required, I can just git stash it, and the code base I can commit again to the master branch. Okay. And whatever git stash is there, it should be stored over there. Whenever the code will be required, then I can pop this thing from stash again and I can work on top of that. So this is the concept of stash. So stash helps to save changes that you are not yet ready to commit. Okay. So I can keep this thing for future purpose and I can work from my previous week's projects. Okay, it's very much important concept we should use actually in our project purpose. Now I'm just moving ahead to the GitHub. Basically GitHub we are using as a service in our project or practical project where everything is being maintained in a portal. Okay, so and there are lots of developers over there. They can maintain the thing. They can check the whatever the latest changes in the portal. Maybe I'm working a particular DDL over there as per a requirement. So I need to introduce a new column for a particular table. Okay, the column was not there earlier. Suppose I'm creating a product dimension table. It's a data mart table. Uh, a particular product, brand level information I need to also keep inside the table. It was not there earlier. It was earlier product ID, product name, particular shop ID. This kind of information was there, but product brand name was not there. Okay, so as per the requirement from the top level management, we need to keep product brand as well in the table. So we have to modify the DDL accordingly, and we have to store the same thing in such a location that all the developers later when they'll be using it, they can check it. So that's why GitHub it's been used as a portal in web. Okay. And it can be controlled. The versions can be controlled over there inside the portal itself. Okay. In the backend, there are lots of memory available. So we can use each of the versions whenever it's required. The functionality is same whatever we have learned and at the Git side, but GitHub it's not exactly Git. Git is a tool, and top of that particular tool, we can use GitHub as a service provider. The same kind of features we can use based on top of an web. Okay. So in practical purpose or in any project, we will be using this kind of services, GitHub, GitLab, anything. So first of all, the particular thing should be maintained in the portal that I told you. But whenever we will be coding, then we can code. We have to code the thing in our local, not over there in our portal. Suppose we are a Python developer or we are a SQL developer. we have to write the SQL or Python code in our local MySQL database, whatever we have learned earlier, or we can develop the code in PyCharm. So whatever tool I'll be using, that should be our local. So first of all, we have to clone the remote repository to our local. In the remote GitHub, it should be maintained for a particular drive structure. So the same drive structure can be downloaded at our local, and it's called cloning part, git clone. So if I just put git clone URL means the particular portal for the git where we are storing our repositories and all. So that can be cloned in our local system. Okay. And whatever changes we can make on top of that thing in our local system. Pointing to that particular code base, I can open our softwares, whatever is required. Any SQL file can be opened, or maybe PyCharm. I can open new file pointing to this local repository, and I can make the changes over there as well, whatever the required changes. Okay, and I can commit the changes so that the commit should be there in our local repository. When everything is fine, I can push the changes to the remote branches again by this command git push remote branches. Okay. So whatever branch I need to replace this thing by branch remote repository over here. So pushing exports commits to remote branches. That's why git push is required. If we are using a graphical user interface, GUI, suppose git desktop, if we are changing anything for the cloning repository in our desktop, it should be showing us that those kind of pushes are pending. I mean, those are changes. We can push it to the repository. I mean, the remote repository. We have the option. We have the switches over there. Just we have to click it. Whatever changes I have to require to push, I just have to click few clicks over there. Just push the changes to the remote branches. It should be pushing my changes to the remote branches, so that after the end of the day, whatever changed I have done in my local repository, that can be pushed to the remote repository as well. Remote means the portal or the URL. Okay. So similar way, uh, when the particular clone is been done, we cannot daily basis clone it. So whatever other developers has been developed, the same thing I can pull at my side. So there are two commands, git fetch and git pull. They are almost same, but a bit difference. Yeah, git push. Git push I already learned it. Git push, git fetch, git pull. Yeah, git fetch and git pull, it's almost same. A difference is there between git fetch and git pull. I'll be quickly telling you. I'll be telling you that stuff. So just the main purpose of this is fetching the thing, fetching the code base from remote repository to your local. Whatever extra changes has been made by the other developer, we can pull it. While pulling it, if we just use git pull, then we can pull everything. And if there is any changes from any other developer, the same thing can be merged in our local. Suppose I have abc.txt file. If I just trying to git pull, so whatever the file consists in the remote repository, the same thing should be changed in my local. Okay. So git pull will be saving the changes at your local, but git fetch will not. It will be just pulling all the all the stuffs from the remote repository, but it will not be committing it at my local. Okay. If I just trying to, if we just, uh, I mean, uh, use git fetch and git merge subsequently one by one, then it should be working as a git pull. Okay. So it can import all the commits from the remote to local, but it will not modify any file till I use git merge command. But git pulls, if we just want to do the single, all the thing at a single go, we don't want to wait anything, or suppose I have to work quickly, whatever changes has been done by the other developers on top of that, then we can directly use git pull. Okay. But for the safer side, if I just want to pull all the changes but don't want to merge it at my local, I just want to make some more changes for today. Then only after that I can merge it. Then we can use git fetch earlier, and later when we have some time, we can merge it into our local. Okay, so that is the difference between git pull and git fetch. It's almost same, pulling the thing from the remote to our local, but a bit different with that concept. Okay, so just a quick example on top of PyCharm. I think this is the last slide for today. So PyCharm, in the PyCharm that we can use in multiple ways if we are using PyCharm. So just like over here, if we just open PyCharm, I think you have already installed it. During Python classes, we learned on top, I mean, lots of things on top of PyCharm. It's worked as a IDE. So if we just clone the thing at our local, then I can open that file, or I can open the particular codes on top of clicking on the on files, open the files, open the directory, and I can point to that particular local code base directory. So I can work whatever I can do over here in PyCharm, and I can save it. When my local repository is updated, I can use some graphical interface tool or Git bash to push the changes into my remote repository. Okay. But nowadays, those kind of IDs has some extra features. We can directly work on top of remote repository itself. Okay. So I can directly connect to the Git remote repository. I have the features. Even I can create some remote branches as well from here. Pointing to a particular master branches over here, I can create some new branches, and I can push or check in that particular changes at the remote side too. So no need to work as of now. If we are quite expert or we know how to work on top of Git, then I can directly use remote branches by PyCharm. I can change whatever changes is required, and I can commit the same thing at my remote side. So we can bypass the downloading part from here. No need to clone the thing. I can work directly pointing to our PyCharm ID to the remote branches. So those kind of features are available in recent IDs. Okay, they can work on top of Git. So you can see all the options are there: pull, fetch, push, clone. Okay, but we need to check which branch I'm currently working on, because if we're developing small things or which is not required, we should not have to push this thing into the master branch. Rather, create a feature branch on your remote side, and pointing to this remote, connect to your IDE, change everything, and check into that particular feature branch. So when your feature branch is ready, you can, by using portal, GitHub portal itself, you can merge your feature branch to the master branch by taking the conditions or checking with your team leads, whatever, which is the suitable date, or your code is ready up to this module. So whether you can merge it or not. Okay. So this is the entire concept, how the team is working on top of code versions. Maybe if you are quite new for the projects and all, you will be there'll be no issue. I mean, you just learn what is pull, what is push, what is commit and all. So maybe, I mean, you are not doing the hands-on part now, but there will be, as you are new to the project, when you will be newly working on top of the project, then you are quite, sure how to do the pull, push, or even the concept is clear. Maybe the interface is not uh, clear to you as you are not doing the hands-on part, but the concept is clear. When the interface is present in front of you, then there will be no issue. Okay, so that's all for today's session. How Git works overall to save the changes or to track the changes for a version control management system. Any doubt for anyone till now? Anything from your side? Nothing? Okay, fine. So, yeah, almost the course has been, the session has been ended. tomorrow I'll be just going ahead with that particular exercise I just gave you for the Python part. So creation of particular data frames pointing to Excel's files and all, and do some operation on top of Python. I mean, by uh, using Python pandas libraries, and after that, push the same tables or data frames to an external database. So I hope you have already tried it. So I mean, tomorrow we'll be just quickly having this thing. I'll be just doing this thing in front of you, and so that I mean, there will be a quick recap on Python chapters, and if there is any other thing to add or any other feedback, or if you want to add some more thing in a future sessions and all, you can ask me. From fifth onwards, there will be new sessions. For the same whatever we have covered over here, the same kind of stuff should be there. But based on the discussion, if there is anything to be added, we can discuss also with the management team, maybe Lohit or any other one. If this is the required one for these courses, then we can definitely add the thing to discuss in the next session. So tomorrow should be our last session. I'll be covering the particular Python recap once more time with that exercise, and we'll be closing that thing. Okay, so let's connect tomorrow. Thank you, everyone. Bye.
Thank you.
Thank you.
Thank you.
Yeah, thanks, everyone.